Hello everyone. Welcome to this NPTEL course on quantum. I'm Gargi Dasgupta. I'm the Director for IBM Research India and the CTO for IBM India South Asia. I'm really excited to have all of you join us, and I want to give you a perspective on the quantum computing roadmap and how we see it evolving. Needless to say that quantum computing is a very fast, emerging, and a key disruptive technology that can significantly affect many industries and society at large. There are estimates that show that by 2024, the quantum computing value is going to touch to 2 to 5 billion US dollars. So what we want to really see is that it reached to a point where real-world problems, ones that could not be solved by classical computers, are starting to get solved by quantum computers. It is indeed seeing an exponential growth in its compute power, something that we term quantum volume, and we expect this volume to grow for some time to come. The quantum advantage is likely to be realized in the next few years, where a real-world problem of consequence will be solved efficiently using a quantum computer that even the biggest supercomputer will not be able to do. And this is what the roadmap is designed for. So as we look forward towards the quantum advantage, it's also important to appreciate what we have today. On your screen is the beautiful quantum computer with one of our research scientists standing in its refrigeration unit and appreciating the sheer engineering marvel that you see on screen. So this is what we have today. This is what is accessible through our cloud to hundreds and thousands of developers. And this is what we have gone ahead and published a roadmap to show the whole community and the whole world how we get from what we have today to where we need to. Now, before I look at the roadmap, I think I talked about quantum advantage. So it's important to understand a few killer use cases, right? Where quantum advantage can get us. And I'll give you two. So we're all going through the pandemic, and this has brought a sharp attention to the challenges of discovering a new drug. Now, if I give you an example, today, a single drug takes about 10 to 15 years and costs multi-billion dollars to go from discovery to productization. And one of the key challenges is identifying a key molecule that attaches to a particle target of interest and not to thousands of others, which is really in the side effect category. Now, simulating a complex molecule is not possible in a classical computer, as the number of states needed to keep track of all its interactions grow exponentially, right? So here lies our first application. Drug discovery and chemistry in general is likely to see a lot of benefits from being able to run these simulations on the quantum computer. The second is around healthcare and diagnostics. There's been many of us who know of people who we have lost either to this deadly disease of cancer or are suffering and had to go through huge treatment to treat cancer. The technology that's used in detection and diagnostics of cancerous cells are today a combination of classification, clustering, simple machine learning problems. However, the classification techniques that are used to identify if cells are cancerous or not are suboptimal, and quantum computing can potentially improve the quality of the results in being able to identify complex structures like proteins, DNA, RNA. So this is the second use case. And the third one, of course, I'll leave you with, because it's also going to be a very important one for our country, is the area of fraud detection in financial transactions and risk prediction for these companies. Right? So those are the killer use cases when once we have the quantum advantage, we should be able to solve. Now back to what I was saying about the roadmap, right? So IBM published the quantum roadmap, and this publishing of the roadmap, making it public, says two things. One is our commitment to the science, right, behind it, and that we continue to push for bigger and bigger breakthroughs in the evolution of the quantum systems. The second is that our belief that we will be able to make the progress that is needed for us to get ready for quantum advantage in 2023. So we see the roadmap starting from 2019 up to 2023. It shows a family of processors: Falcon, Hummingbird, Eagle, Osprey, and landing in Condor. And Condor is the one that everyone has their eyes on. It has a quantum volume of over 1,000 qubits, and it seems like it's ready for solving some real use cases. Now, I use the notion of quantum volume. It's important to understand what this volume is. So quantum volume is a metric that measures the capabilities and error rates of a quantum computer. It expresses the maximum size of the square quantum circuits that can be implemented successfully by the computer. The form of circuits is independent from the quantum computer architecture, which means that quantum volumes from different architectures can indeed be compared. Right? So you see the inflection point just before 2023 of the quantum volume, right? And that's what we all are looking for. So two things that I wanted you to take away from this roadmap is that there is a published roadmap of our processors, and these processors, actually it's important to know this, these are family of processors. Eagle represents a family of processors that have a quantum volume of 127 qubits. And the advantage is that that everyone now knows what's coming, so that they can design their quantum roadmaps. All our partners could design their quantum roadmaps accordingly. And it's also important to note that there is a huge advancement of the volume from one family of processors to another, landing us in an over 1,000 qubit machine by 2023 and getting us ready for real use cases. Now, knowing that this is the published roadmap, the next task is to make sure today we are engaged in the ecosystem of developers, of our clients, to make sure that we are engaging on the right use cases, that we have access to real quantum computers, not simulators, and that we have the scientists and the developers and the subject matter experts in use cases together being brainstormed on with the use of some communities and quantum networks. So we do this chart shows the roadmap also from a software perspective. So the previous one was the hardware roadmap, and now that we know what's coming in the hardware, it's easier to build communities and of people who can focus on building on top of the quantum systems, and then really start getting us ready for the time when enterprise clients are going to be able to integrate quantum in some of their business workflows. So that's what this chart is about. So the quantum systems, the bottom layer is what I showed you in the last chart. Then comes the community of developers, the kernel developers who sit on top and create the runtimes. And one of those runtimes, the Qiskit runtime, is something that you will study at length in this course. Then there are dynamic circuits, there are circuit libraries, and then going on to advanced control systems. So that's the persona or the set of community of developers who are going to actually contribute to building these runtimes itself. On top of them sit the algorithm developers who are going to take these runtimes and create some pre-built quantum libraries and toolkits for certain domains. And I gave you some examples of drug discovery, of natural sciences, finance use cases. Then there's several machine learning optimizations that could be done using quantum. Each of these disciplines and domains will have a set of algorithm developers who will create these pre-built runtimes for the domain of chemistry, for natural sciences, for financial forecasting, and make these available by, we think, our estimate is around 2023. And then on top of that, we start realizing, so the community of model developers start and take a particular use case and build a model using the quantum runtime. And that model could be to find the new and the next best drug in exponential less amount of time. It could be to do anti-money laundering of all the financial transactions happening across the banking sector. And it could be any other model that we feel. It could be a faster detection of cancerous cells. It could be any other model that the society feels is going to move the needle. So all of that, if you look at the 2023 axis, is happening around that time when we reach quantum advantage. And then once we have these use cases solved, enterprise clients can start building on integration of these models into their workflows, right? Now, in order to do all of that by 2023, we need to start now. We need all of you who are part of this course, your friends, people who are interested in quantum computing, to start understanding and creating these skills. And you could choose whether you want to be in the hardware space, you want to be a kernel developer, you want to be an algorithm or a model developer. The choice is yours, but the skills need to be attained now. All right, so moving on, I think the last thing I wanted to tell you is that, this is really exciting for us. This is exciting in so many ways because it's creating the next generation of systems, is creating a set of personas that are going to build on top of this system. So new skills, new development capability needed, and developers are going to be at the front and center of this quantum evolution, right? So, and today there are software development kits like Qiskit that are so much in demand that the developers could start using and getting access to quantum computers on the cloud, real quantum computers, not simulators. And that is really a breakthrough, right? The way we offer access to the latest and the greatest hardware system that our scientists are developing with access through the cloud is really a breakthrough, and urge all developers to take advantage of this. And this is not just us talking about it. There's a survey from Burning Glass that shows that the skill area that's projected to see the fastest growth is quantum computing, right? So we have to work towards the future. We have to build quantum ready skills. You have access in the open source to Qiskit. You have access to IBM quantum computing machines. So let's make use of it. We've made some headway with the major institutes and universities in India in 2020 and 2021. We saw, the leading universities like ISI Kolkata, University of Calcutta, Indian Institute of Technology Madras, IIT Kharagpur, and Indian Institute of Science, Bangalore, all starting their courses for students to accelerate their training in quantum computing, right? So that's something, a trend that we've seen. And there's also an introduction to quantum computing and quantum hardware by Qiskit. This is available material. It includes labs and hands-on sessions. And anyone with some basic knowledge of linear algebra and Python skills could now get started on quantum computing and access the machines via cloud, right? So this is really great. And I urge every one of you, after you take this course, to go back and take these reiteration courses. And I'm really looking forward to each of you working on quantum computers and accessing via the Qiskit open source framework. And who else is doing it, right? That's what you will ask me. So this is our snapshot of the quantum network. We have about 247,000 users who's run over 400 billion quantum circuits on 29 quantum computers, all of them accessible through the cloud. We have more than 130 clients and partners in our network. They're all brainstorming to build about 30 plus applications, and some of them could be in the areas of drug discovery, financial fraud, medical diagnosis, but there could be so many more. And we urge you to think, if you're part of an enterprise, to see what are those applications. We also have over 300 contributors to Qiskit, and if you are interested in, making a dent on the open source community, we welcome you to be a contributor to Qiskit. And then there are 400 scientific papers so far. So overall, it's a really bright space. It's something that we absolutely have to work now to make a difference tomorrow. And that tomorrow will be no less than landing a man on the moon. Thank you and enjoy your course.